You ready? Okay, you guys could keep going on. I'm pull it all up.
Okay.
Wait.
Cool. So, sorry, I gotta pull it up too. Let's find the right page here.
Is the tutor not in this one?
We
She
talked
left.
first.
She left.
Yeah.
Perfect.
So she just answered a couple questions and then took off.
Oh really?
Yeah.
Yeah.
Okay, cool.
So we want to just go straight to the group quiz again, or?
Mhm.
Okay.
Yep, that sounds good to me.
Okay. Cool. Alright. So 1 and 2 we can kind of answer on our own.
Yep.
If you can't answer that, I can't help you there. Okay, so number 3. In previous lessons, we've assumed the population standard deviation sigma was known. In this lesson, we are making a different assumption about sigma. What has changed?
Sigma's always unknown.
Yep.
Hmm.
Okay, come on. Why is it not letting me? Okay.
The null hypothesis is mu equals 8, and the alternative hypothesis is mu is greater than 8. And the population standard deviation sigma is not known, but it collects a sample size of 9 and computes the average of 11. And the sample standard deviation is 6. Use this information for questions 4 and 5. Is sigma known? Well, no.
Yeah.
Yeah, no.
What is the value of t? So you just kind of plug that into the, what do you call that? The equation, correct?
Mhm.
Yeah. The student T equation or something like that?
Yep.
Yeah. Okay, fine. 11 minus divided by 11 square root of.
Did you guys get 1.5?
Where- Yeah.
Cool.
So what you got, Faith?
Yep. Sorry, I had to find my
Okay.
calculator.
Oh, okay.
I don't have mine either. I'm using my phone today for my calculator.
Oh, that's always fun.
Oh, always. Especially when you're in chem, huh?
Oh, gross. No, never in chem. Okay.
Do you guys have SPSS on your computers?
Mhm.
Yeah.
So I'm on my iPad, and I don't have it on my iPad.
Okay.
So I can't log into it.
Okay. That's fine. So we can pull it up.
Okay.
Yep.
Okay. So use the following values, which are pulled from the data file body temp. Copy and paste them into the software you're assigned to use. Using the null hypothesis of mu equals 98.6, an alternative hypothesis that mu is less than 98.6, and the level of significance of 0.05. What is x bar? So our average. Let's pull up SPS.
This is the one that the tutor talked about, correct?
I think so, yeah.
What did she say?
She said.
She kind of explained what the numbers meant, right?
Yeah. So
Okay.
the mean is like the 98.234.
Mm-hmm. And that's oh no, that's just the mean, huh? 98.234.
Is that what you got, Faith?
Or is that our average?
Just entering them real quick, sorry.
Because it says right there on the t-test, but I don't know. Oh, I don't know anything.
Yeah, I'm still just entering the info, so just a second.
Okay.
And then you have to calculate S on SPSS, right?
Yeah, it's kind of given to you in SPSS.
They don't, because in the reading it doesn't give you how to calculate it by hand. Right?
I don't think so. No, not for this one.
At least not in the textbook one.
Yeah. Okay. Sorry. So for average, what did you get again?
Oh wait, hold on. I was just using like the numbers that they use. I didn't use these ones. 98.8, 96.8, 97, 98, 7, 97, 6, 98.7, 98.2. Okay, so then we go to analyze. And then you put like the options. No. You put the test value at 98.6, right?
Yep, because that's what we're comparing them to.
Okay. So I got the mean of 98.1316.
I got 98.2316. Let me read through the data point and make sure I entered them in right.
98.2, 99.6, 97.6, 97.1, 99.1,
Oh, there we go. Make sure.
Oh, I missed 99.9.
I think I missed one too, so. Let's see.
6. 7. let's do this again.
Yeah. Okay.
I got 98.2200.
Same.
Yay!
Nice.
Okay, perfect.
And so
what is S? So for that we got 0.922.
Uh-huh.
okay. And then to make the T-score, let's see.
And we actually got the T-score in all of our info too.
Oh, really? It did? You didn't have to calculate it out?
Mm-hmm.
What'd you get for it?
Negative 1.843.
Yep.
Okay.
And so what is our p-value? So it's the same thing as that sig two-tailed thing.
Mm-hmm.
0.081.
Mm-hmm. Oh, wait. Does the p-value, doesn't that change depending on what the alternative hypothesis is? So with this one, since it says that it's mu is less than 98.6, we would divide that number by 2.
Okay.
Oh, because that's like the two-tailed, right? So we're like trying to just get one side.
So it would be like when we look at the normal applet, it'd be like having both ends shaded in when we really only need one.
Okay, so when you divide that by 2, it's 0.0405.
So 0.041 if we round it.
Yeah.
And this, we would reject the null, right? Or fail to reject the null, I mean. Because it's bigger.
That's actually less than 0.05. What was the p-value?
0.08.
Or the level of
oh, you're right. I didn't change that. It's 0.051.
Okay. So yeah, we would reject it.
Yeah.
Yeah, gotcha.
Okay.
I was looking at 8. When you said it was smaller, I was like, that's an 8.
Oh, okay. Fun stuff.
The following values, which were pulled from the data file Baby Boom, these values are the wait time in minutes between births at hospital. Copy and paste them into the software you are assigned to use. Awesome.
Okay. Basically doing the same question again. Okay, we'll plug this in real quick. So you guys doing anything fun for the long weekend while we're plugging these in?
Dude, I need Valentine's Day ideas, guys.
Okay.
Start throwing them my way.
You can just copy and paste them.
Yeah, that's what I'm just doing too. I don't know why we didn't do that on the last one.
I know. So what was the average or whatever? Like, what's the test value?
40, right? Because we're testing it
Yeah.
against that hypothesis.
Should be, that's your null.
Well, do you have a particular person you're taking out for Valentine's Day, Brad? Because that changes what you want to do for Valentine's Day.
No, I need to find a girl first.
Good plan.
I'm just kidding.
Okay.
You can take her to dinner.
Always a solid choice.
What kind of activity would be good too? If you guys could go on any Valentine's Day, what would it be?
If for like a first date, or for like you've taken this girl out a few times?
Me and my girlfriend have been dating for 1.5 years.
So. Okay. Whoa. So it needs to be something super cool.
Yeah.
Like, does she usually like super simple stuff, or like actually super fun, go do something really active type deal?
Dude, it all depends on her mood. It flip-flops so much.
Okay. I don't even know.
Horseback riding, that's fun.
Yeah.
Mm-hmm.
I wish I
had
had some
like a
horses.
picnic.
Where do you get some horses at?
Have you looked at the outdoor learning center? I know that they have stuff like that.
That's true, they do.
Or you can just like keep it super simple and just like have like her favorite movie and like food and bring it over to her and just like have a chill.
Go get some Taco Bell and watch a movie.
Yeah.
Yeah.
What?
And
That's
like,
what I'm thinking.
But bring her like flowers with it to make it extra special.
Yeah, make it a little bit special.
Oh, okay. Good idea.
And you should like put it out on a blanket so it's like a picnic right there in her room.
Oh my goodness, but too bad I don't break the honor code, Kimberly. I don't go in her room.
Well, not in her room, like in her apartment.
I'm just kidding. All right, guys. What do we get for the for the p-value?
We got a little distracted there.
Yeah.
For our p-value, wait. So are we looking for a p-value or a t-value?
P-value.
Okay. It would be 0.995. Is that what you got?
Yep.
And you have both sides shaded in because the alternative's anything but 40.
Yeah.
Yep.
Okay.
Okay. So what decision do you make?
You would reject the null. No.
You would fail.
You would fail to reject the null.
Mhm.
That's right.
What does that even mean? Like fail to reject or reject?
It means the null's correct, right?
Yeah. So you would keep it. It's like a double negative.
It really is.
It's really annoying.
You should just have reject the null and accept the null.
Yeah.
So that's basically all it means. And then so when you fail to reject the null, it means you don't have enough evidence to say that the null hypothesis isn't true.
Mm-hmm.
Okay.
Deal. And then if you were to reject the null, it means that you have enough evidence to say this isn't right, but the alternative one is.
Okay.
Mm-hmm.
And since like the p-value was large, that means like there's a lot of evidence.
Mhm. Yeah, because the level of significance is 0.05, so it's much larger than that level of significance, and so that means that there's not enough evidence that you would like to have to get rid of that null hypothesis.
Okay. I get ya.
Okay.
Mm-hmm.
Okay.
So this next one, if you change it to where the alternative is less than the null, would you keep the same level, and you keep the same level of significance? Did your p-value increase or decrease? It decreased because now you're only looking at one half of it, right?
Yep.
And then you still, if you divide that in half, you're going to have 0.5 something, and so you'd still reject the null.
Fail to reject the null.
Or fail to reject the null. That's what I had clicked. And that's what I meant to say. It's that double negative. Then compare the width of the confidence interval for question 11 to the confidence interval for question 13, which is wider. I'd say question 11, right? Because it's pretty obvious that you're going to reject or fail to reject the null no matter what in question 13.
Mm-hmm.
Oh wait, sorry, never mind. I was thinking from the first set of ones that we did, first set of information.
Yeah.
You're confident.
So like, in the lesson or whatever, you can. It says like, click here to see it, and so like the closer you get to like 10, the wider it is.
So,
and so like, I put in like 1 and it's like super narrow, I guess. And so I think it's question 11.
Yeah, because it's so close to 10.
1.
1. Okay.
Does that make sense?
Yeah.
Yes. I don't know. That's the one thing I need to go over because I don't quite get that yet.
Like the degree of freedom or whatever?
Well, I can get the degree of freedom, or the, degrees of freedom, but I don't get, like, I get it when they were talking about the confidence interval and, like, how as your confidence interval actually gets bigger, so, like, 99% versus 95%, it's actually, like, widening. Or, it's not quite what we're talking about, so, just kidding. We'll just go with 11. Well, I'll figure that out later.
I'm sorry if it's wrong, guys.
No, it's okay. I am running on like 3 hours of sleep, so I'm just like, sure, we'll just go with it.
Yeah, I've got 5 under my belt, so we're good.
Yeah.
Alright.
Ready?
Let's
Yep.
do it. Yeah. What did we miss?
Ah,
Dang it!
they're the same.
Oh, are you kidding me?
I guess that would make sense because it's a 95% always a 95% confidence interval is assumed. So that didn't change, just your p-value changed.
Wait, say that one more time.
So whenever you put in data into SPSS, it automatically assumes that you're looking at a 95% confidence level interval.
Mm-hmm.
And so we didn't change that between the two questions.
Oh, okay.
We only changed that we were looking at the p-value.
Okay. All right.
Which is still kind of confusing, but we did.
So you just assume that the confidence interval is the same for all of them.
Yeah, for these ones. Because, and I guess that kind of makes sense. So when you looked at, so if you were to look at it like a normal probability applet thing, so if you kept it at 95%, but then you only looked at like one side of it, you never changed the width that you were looking at. You only changed like what shaded parts you were looking at. So you never changed the width of this.
Yeah. That's true.
So I guess
that makes sense right there.
Yeah. So, well, good job, guys.
Cool.
Yeah.
Well, all right, guys. I got to get back to work, but
Okay, sounds good.
I will see you later.
Yeah, see you Tuesday.
Yeah. Have fun on Valentine's Day.
You guys too.
Thanks.
See ya.
Bye.
Bye. Okay, bye.
Bye.